Welcome to Mathenatic. We are revising sequence and series for paper 1. A rubber ball falls from a height of 1 meter above the ground. It bounces back to a height of 9/10 of a meter. It falls again and returns to a height of 9/10 of the previous height. Calculate the total distance moved by the ball up to the time it hits the ground for the 5th time. For this solution, I found it helpful to draw a diagram. So a ball is dropped from 1 meter. Then once it hits the ground, it returns to 9/10 or 0.9 of its previous height. Then from that height, it drops down again to hit the ground for the 2nd time. And then we have a new height and it returns to 0.9 of that height. So can you see it's now 0.9 squared of the original height. Then it drops down to reach the ground for a 3rd time. And that pattern continues up until the 5th time that it touches the ground. So can you see, other than the first drop, we have up and down movement for the 2nd, 3rd, 4th, and 5th bounce. So what we want to work out is all of these up and down arrows, the distance that the ball has traveled all together in terms of vertical distance. So let's represent that information as an equation. So we have 1 plus 0.9 times 2 because it is up and down movement. So that 0.9 is represented twice. Then we have 2 again times 0.9 squared. And the reason why we square because this represents the second 0.9 from the original height. And can you see that the final bounce up until a down movement is 0.9 to the power of 4, and that 2 represents up and down. So if we add all of these values together, we get a total vertical distance of 7.2 meters. Thank you for watching. Support us by liking and subscribing to Mathenatic. Check out our Digistore for math study notes, with free downloads for statistics and financial math. Follow the link in the video description.